Huh. Hello everyone. So chalo, we are going to do what? We are going to do the nomenclature first, then we'll move forward. Okay. So first let's start with the example 9.3. Example 9.3. Example. बताओ. What is the first question? And we'll follow the rules. Rules open करो. Ligands का page open करो. ठीक है ना? First क्या है? What is the question? Tell me.
IUPAC name of PT
PT
NH3
NH3 or 2
Cl
Cl
NO2
NO2. Okay. NO2.
third bracket.
This much only.
Yes, sir.
Okay. Fine. So so this is the complex only. There is no counter ion. Complex ion is there only. Right? Okay. Now see the rule. First rule is what? That you have to name the positive ion first. Right? Whether it is complex or counter. Positive ion. Now in this case there is no question of any positive ion because that is whole as a neutral only. Okay, there is no counter ion. Okay. So you have to name the complex. You have to name the complex. See the second rule. See it. See the second rule. What is the second rule? Do see and do as I said. What is the second rule? That in a complex क्या क्या होता है? Central metal ion होता है, ligands होता है, right? So obviously ligands has to be named before the central metal ion. Clear? Okay. Abhi ligands, how many types of ligands are there? 3 types of ligands are there. You can say 3 types. What is the central metal ion? Platinum. And 3 types of ligands are there. Are these all in your list?
Yes, sir. Yes.
This is amine. NH3 is amine. Clear? You have, this is chlorido. Chlorido. But you written chlorido. Please, that list should be ready. Okay? This is called chlorido. Okay? This is monodentate ligand and monodentate ligand and the valency or oxidation state is -1. Okay? See, whenever I say chlorido, you see there is one rule. See the rule? One rule is there. The ligands are named by suffix O
Yes, sir.
with some exception.
Yes, sir.
Generally we call it chloride, right?
Yes, sir.
But we coordination compounds, so we call them chlorido. Okay? Fine? Okay? So that is the rule. Okay? Obviously there is some exception. Still now whatever we studied, we did not write O in that. Okay? Fine. NO2 is what? NO2, NO2 is a ambidentate ligands. NO2 can be written as NO2 or it can be written as ONO. Okay? See, it's very simple. NO2 means we had seen that in this that one also, silver nitrate and sodium nitrate in the ambidentate nucleophile. Okay? Here the thing is, what is that called? The donor site is nitrogen. Here the donor site is oxygen. Okay? So here, since the donor site is nitrogen, we write it as nitrito N. Okay? So the name of it is nitrito N. That is what I am saying. That list is completed, you can do anything. Okay? Nitrito N. And this is called, obviously, this is called nitrito O because O is the donor site. Nitrito O. Okay? So we have to distinguish them by name, right? What ligand we are writing. Both has valency -1.
Yes, sir.
Both has valency or oxidation state -1. Okay? And both are monodentate ligand. Both are monodentate ligand. Fine? Then, so this is done now. Now, this particular complex is done. Now, another rule is there. If more than one ligands are there, they have to be named alphabetically. They have to be named alphabetically. So, what is this? This is amine, this is chlorido, this is nitrito N. So, which has to be named first? Amine. How many of them are there? 2 of them are there. Another rule is there. If it is monodentate, and 2 are there, we have to write what? Bi. Okay? If it is monodentate and 2 are there, we have to write bi. Right? So what we are going to write? Bi amine. You told double M, I am writing double M. Die by anything. That doesn't matter. Okay? You can write diamine also. No issues. Okay? If it is right di, better to write di only. Chalo, I have written di na over there. Okay, chalo. Diamine. Fine. Diamine first. Then what? Chlorido. Okay. Chlorido. Then nitrito N. Done. Then the metal. What is the metal? Platinum. Now this is neutral, so we are going to write down the name of the metal only. Right? Okay. And after naming the metal within bracket, we have to write its oxidation state in Roman. That's another rule. See? That's another rule. We have to write down the oxidation state of the metal after writing the name of the metal within bracket. Clear? Okay. So what is the oxidation state you calculate? This is X, right? 0, -1, -1. So tell me what is the value of X? Plus 2?
Yes, sir.
Yes? Okay. So I'm going to write 2 in Roman. That's the name of the compound. Is it clear?
Yes, sir.
Understood that? Chalo, अगले वाला बताओ. What is the next one?
So K3
K3,
under third bracket.
Yeah.
CR
Cr,
C2O4 whole size.
C2O4 whole thrice,
And
bracket closed. So here what is the ligand?
C2O4.
C2O4. What is the name of it? Oxalato. Oxalato. Okay, this is oxalate ion. Oxalato. Okay, that is what I am saying. Whatever ligands will come, you should make a list of it. Oxalato. This is a bidentate ligand.
Yes, sir.
Okay, and the oxidation state is -2. -2. CO negative, CO negative, -2. Okay, so now tell me the name. Here, the positive ion is the counter ion
Yes.
and negative ion is the complex.
Yes, sir.
Right? According to the rule, the positive ion has to be named first. So, first of all, we are going to write potassium, right? Yes, positive ion has to be named, means positive ion is potassium, potassium is named first. Then we have to name the complex. Clear? In the complex, obviously the ligands has to be named before the central metal.
Yes, sir.
What is the ligand? Oxalato. What type of ligand? Bidentate. If it is bidentate and more than one is there, how do we write?
Trace.
Base trace, right? Okay, so 3 are there, so it's trace, right?
Yes.
Okay, so trace oxalato. Oxalato, just following the rules, but that's all. Trace oxalato. Okay, then the metal is chromium.
Yes.
Okay, but since the complex is negative, if the complex is negative, see another rule. The name of the metal is suffixed by ate.
Yes, sir.
When the complex is negative. When the complex is negative. So chromiumate, right? Chromiumate. But we don't write chromiumate. It sounds better. It sounds not good. That is why we write chromate. Okay, we write chromate. Okay, but 8 is coming for what? You understood that? 8 is coming for because the complex itself is negative. Okay, and after writing the name of the metal, obviously we have to write down the oxidation state within the bracket. So calculate the oxidation state and write it down. K is +1, Anna? And this is -2. So calculate it. So 3, chromium 3, right?
Yes, sir. Yes.
It is coming as 3 in Roman. Is it clear? Understood that? Okay. Next, so I think you can do the nomenclatures now. Okay? You will try the nomenclatures now. Just see and tell me the ligands. Ligands बताओ. कोई नया ligand आएगा तो उसका नाम लिखो. वो list बनाना है. मैं बार-बार बता रहा हूँ. Ligands बताओ. क्या-क्या है? Third question में ligands क्या-क्या है? Next question में? हाँ? En. En is ethane diamine. En is ethane diamine. Okay? Ethane diamine. Okay? This is a bidentate ligand. And the valence is, yes, bidentate. Ethane diamine is what? This one. CH2, CH2, NH2, NH2. Okay? There are 2 donor sites are active at a time. Fine? Okay? This is a bidentate ligand and the valence is obviously 0 because this is a neutral molecule. Okay? Oxidation number is 0 because this is a neutral molecule. Okay? So you can write down the name. If you know the name of the ligand, you can write down the name. There is no issues over there. Yes?
Yes, sir.
Yes? Okay. Next. क्या ligand है?
Amine or
बताओ कोई दिक्कत नहीं है. If you don't know, doesn't matter. Huh?
CO3.
CO3. CO3 is carbonato. CO3 is carbonate ion, right? CO3 2 negative is carbonate ion.
Yes, sir.
We write is carbonato. Carbonato. CO3 2 negative is carbonato. Okay? Carbonato. It has got I mean, it is simply monodentate ligand. Carbonato is monodentate ligand. Okay, and its valence is -2. -2. Carbonato. CO3 means carbonato. Okay. Next one.
HCl.
SCN. Thiocyanide. Thiocyanide. Again SCN में दो चीज आएगा आपको याद रखना. SCN और एक आ सकता है CNS, है ना? These are also ambidentate ligands. SCN में I mean S is the this thing donor site, and CNS में N is the donor site. Okay? These are ambidentate ligands. This is called thiocyanide. Okay? This is called isothiocyanide. This is called isothiocyanide. Okay? Thiocyanide and isothiocyanide. Clear? Okay? Monodentate -1. Monodentate and -1. Then next one. ये क्वेश्चन हो गया. हाँ, चलो अगला क्वेश्चन. नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन मीन्स नेक्स्ट इमीडिएट नेक्स्ट क्वेश्चन. नो. नेक्स्ट एग्जाम्पल क्या है? उल्टा है. क्या है? वहां पे नाम दिया हुआ है. You have to write down the structure.
Yes, sir.
That is another thing. Yes, tell me. Tell me the first one. What name is given?
Tetramine.
Tetraamine. Okay, just a minute. I'm writing it. Tetraamine. Tetraamine. Aqua.
Chlorido.
Chlorido.
Cobalt 3.
Chlorido. Cobalt 3.
Chloride.
Chloride. Write down the structure of it without saying that. Just write down the structure of it. Write down the formula of it. Simple. Write down the formula of it. All you know, amine you know, aqua you know, chloride you know. Yes? Okay? So write down the formula. And what is the positive ion? Complex or the counter ion? Complex. Chalo, write down the structure. Write down the formula of it. एक ही चीज, इसमें एक ही चीज मेरे को बोलना है बस. लिखने के बाद मेरे को बताओ कि व्हाट इज द फॉर्मूला, व्हाट इज द स्ट्रक्चर यू हैव रिटन और फॉर्मूला यू हैव रिटन. बताओ. बताओ. टेल मी. CO square bracket, right?
Yes, sir.
CO
NH3.
NH3 whole 4 H2O
Cl.
Cl bracket closed Cl. ये लिखा है आपने सबने? Everybody has written this? Yes? Now tell the name of this. Tell the name of this. Forget about this. You write down the name of this. This compound is given and write down the name of this. नहीं, अब लिखो ना पहले, इसका नाम लिखो आप. Cl2 कहाँ से आ रहा है? तो क्लोराइड होने से Cl2 आता है क्या? कौन बोला? क्या दिस इज डिफरेंट? आप लिखो ना नाम. अब नाम लिखो ना इसका. You write down the name of it. I'm teaching you something. Don't think just joking. आपने ये बोला नाम. From the name itself, you said that this is the formula. Okay, fine. Now write down the name of this formula. Forget about the name that is given. You just know the rules, and this compound is given. Write down the name of this formula. Name of this compound. Lick. Indrajit, write down the name of this compound. Yes? Done? Bata. What is the name of this compound? Tetraamine, yes? Tetraamine. Aqua. Chlorido. Yes? Cobalt. उसके बाद ऑक्सीडेशन नंबर लिखना है. क्लोराइड कितना है ऑक्सीडेशन नंबर? कैलकुलेट करो. This is 0 0
minus 1
-1 कहाँ आ रहा है? This is 0 0, this is -1, this is -1. So cobalt का कितना आ रहा है?
plus 2
+2 आ रहा है. Right? Yes. So is it the compound that has been given to you?
no sir
नहीं है. इसका मतलब आपने गलत लिखा है?
yes sir
इसका मतलब आपने गलत लिखा है? Yes. Understood my point or not? Okay, understood from your mistake. Then you will never do mistake. Yes. क्योंकि हम लोगों ने क्या किया, हम लोगों ने just whatever is written we just wrote it over there. Okay. अभी आप देखो, just I'm telling it in a very simple way. What is the formula of potassium chloride? KCl. What is the formula of magnesium chloride? Why MgCl2? Why not MgCl? If KCl is potassium chloride, why not MgCl? Aluminium chloride? So why not? है ना? क्योंकि इसका valencies are different, right? Valencies means oxidation states are different, right? Okay? So oxidation state has to be taken in consideration. मैं chloride बोलने से इसमें भी मैं potassium chloride बोल रहा हूँ, magnesium chloride बोल रहा हूँ, aluminium chloride बोल रहा हूँ. But chloride बोलने से एक ही chloride होगा ऐसे कोई नहीं है. How many chlorides will be there? That does depend on the oxidation state, right? Yes. So we don't know how many chlorides will be there here. That we don't know. Okay. We are going to write ClX. We don't know how much is. Clear? Now we have been given the formula. We have been given the name. Okay. Now according to the name, we are going to find out the value of X. जहाँ पे कोबाल्ट का ऑक्सीडेशन स्टेट आपका दिया हुआ है +3. Yes. Yes or not? Okay. Now find out the value of X. What is it? See, 3 plus 0. Yes, plus 0 minus 1 into X. Yes, minus X should be equal to 0. So X is equal to how much? You see, it will come to, just check it out. Is it coming to? Yes or not? Okay. So what should be the formula? The formula should be, yes, be careful of that. Understood my point?
yes sir yes sir
Yes. It is not chloride there means it says the chloride means only one chloride. Okay. So you have to know that it is aluminum chloride also is chloride. Magnesium chloride is also chloride. Potassium chloride is also chloride. Not only chloride, I mean anything. We write it like this: aluminum sulfate, magnesium sulfate, potassium sulfate. Everything is same only. Name is same. But obviously sulfate सब में एक ही नहीं है. Yes. Understood that? So we must calculate the oxidation state. Whatever is not given, we must take it as X. Because the oxidation state of the metal is already given in the name. So you already know the oxidation state. Only thing we know is that how many chloride will be there. That we have to find out. चलो एक कर लो यार. Any one of them is useless to do it. कुछ भी नाम बताओ.
potassium
Potassium, yes. Yes. Next one will tell. Potassium, yes. Oxalato.
aluminum 3
Okay. चलो. Potassium trioxalato. 3 होगा ये actually. But anyway, there's somewhere they use also this trioxalato. Aluminate 3. Okay. So what is the counter ion? What is the complex ion? Potassium is the counter ion, right? So potassium bracket का बाहर रहेगा और bracket का अंदर रहेगा aluminate means aluminium and a trioxalato means C2H4 C2O4 all 3. Okay. Again the same thing. What is the formula of potassium chloride? KCl. What is the formula of potassium sulfate? K2SO4. I am saying potassium only. Yes. So you don't know how many. Potassium means how many potassium you don't know.
yes sir
So we will write what?
6
Kx. Yes. Okay, understood that. And we are going to find out the value of x. Calculate it. What is the value of x? आपको सबका ऑक्सीडेशन पता है. इसका K is how much? +1. Aluminium is +3. This is -2. है ना? चलो x का वैल्यू पता करो. How much it is coming? जो भी आ रहा है, whatever it is coming, I don't know. This is x plus 3 minus 6. So x is equal to 3 coming, right?
Yes, sir.
Huh? So if it is 3 coming means what should be the formula? The formula should be K3. Yes?
Yes.
That is the mistake the students are doing. They don't know it. Because they don't know it, my students won't do that. Yes? क्योंकि उनको पता नहीं है तो सिर्फ K लिख के आ जाएगा तो सोचेगा हम तो करेक्ट लिखा है लेकिन मिलेगा 0. समझ गया बात?
Yes, sir.
Yes, understood that? Very good. So now you can do anything. Once again, I am saying you will try all now. Okay? Some more ligands you will get. I am telling you. Which you might not be knowing. So दोनों साइड में ट्राई करेंगे आप लोग. मतलब स्ट्रक्चर दिया हुआ है, नाम लिखेंगे, नाम दिया हुआ है, स्ट्रक्चर लिखेंगे. You will try some more ligands. You might not be getting it. Fine, absolutely fine. लेकिन वो लिस्ट में आपको आना चाहिए. अगले दिन आके मेरे को पूछना सर ये लिगैंड मेरे को नहीं मिला. ये बताओ. क्योंकि अगर आपको लिगैंड मिल गया, you can do everything. The thing is clear. The concept is clear.
Yes, sir.
Okay, that you can do the naming of the compound or the name is given, you can write down the structure of the compound. Okay, only thing you have to know the ligands. वो लिस्ट आपके पास होना चाहिए. और ये देखेगा जैसे करते जाएंगे ना, you will see that these are all commons only, that you don't have to remember, automatically it will be remembered. एक दो बार करने से automatically it will be remembered. ठीक है, because these are all common only. ठीक है.
NH4 का क्या होगा?
हाँ बेटा,
NH4 का क्या होगा?
NH4 कहाँ है बता? NH4 लिगैंड नहीं हो सकता है.
NCH क्यों नहीं देगा सर?
लिगैंड नहीं हो सकता है. देखो बताओ बेटा कौन सा क्वेश्चन. NH4 cannot be a ligand. NH4 बाहर में हो सकता है. That is the difference.
Condition for भी नहीं देगा.
हाँ बेटा,
Condition for
either I told you that either it is a negative ion or it must be a neutral molecule with lone pairs of electrons. है ना? NH4 हो ही नहीं सकता. If it is there somewhere, that is a printing mistake. Okay? Because it is neither a negative ion nor a neutral molecule with lone pair of electron. NH4 is NH4 positive only. Right? Okay, it might be in the positive part of it. So you understood the nomenclature, right? Clear? Next we are moving to the isomerism. Isomerism of coordination compounds. Isomerism. Okay? See, isomerism of coordination compounds. These are all important. And again, you just listen to me, बस that's all. हो गया, तभी बात खत्म. Listen to me और करते रहो मेरे साथ, बस. Isomerism. What is isomerism? All of us know that having the same molecular formula but different structures. Structures are different, right? These are called isomers. Okay. Now complex में दो type का isomerism होता है. There are two types of isomerism. One we call structural isomerism, and one we call stereoisomerism. Okay. There are two types of isomerism: structural and stereo. Already we know the difference between structural isomerism and stereoisomerism because we had seen it in class 11 also.
yes, sir.
Structural isomerism means what? Where the bonding completely is different. Suppose A is bonded with B and B is bonded with C. A is bonded with B and B is bonded with C. In the other isomer, maybe B is bonded with A is bonded with C. These are isomers only, so bonding is different one. Clear? Okay, that is structural isomerism. Where the nature of the bonding is different only. The compound molecular formula is same but the bonding is different. But if the bonding is same, but the difference is in the spatial position, means position in space. One A and B, A is bonded with B and C like this. Another one, B and C is bonded but A is bonded like this. See, here the bonding is same only. But यहाँ पे A ऊपर है, एक जगह में A नीचे है. Okay? The differing in their spatial arrangement. Okay? Then those type of isomers are called what? Those type of isomers are called stereoisomers. We know it. Already we know it. Clear? Okay, so that is nothing new for us. Now structural isomer आपका syllabus में चार ही करेंगे हम लोग. Okay? Structural isomers of the complexes can be of four types. The first one is ionization isomerism. What is ionization isomerism? See, I'm just writing the example, you can automatically understand it. Okay? And it's not that I am remembering the examples. ना आपको remember करना है. Question कैसे आता है कि two isomers will be given and you will be asked what type of isomerism is shown in it. Understood my point?
Yes.
So you must have the concept that what type of isomer is it. Two isomers will be given, not two pairs of isomers will be given. In which pair, what type of isomerism is found? Okay. So that just you have to know that what are the isomers. I mean, what is the concept of the different types of isomers. So first is ionization isomers. नाम से पता चलेगा आपको. I'm just writing it over here. You can understand that. Suppose CO H2O whole 5 Cl Br. I'm writing it like this. Okay. Fine. This is one of the coordination compound. And another one of the coordination compound I'm writing CO H2O whole 5 Br Cl. See, first of all, are they have the same molecular formula or not? They are having the same molecular formula. So they are isomers. Clear? But if we dissolve them in water, the first one will get dissociated as this positive, this negative. Yes? And the second one will get dissociated as this positive, this negative. So how they are differing? They are differing in the formation of ions in the aqueous solution.
Yes, sir.
Formation of their ions in the aqueous solution, the ions are different. कहीं पे कुछ ligand है, कहीं पे कुछ दूसरा है, या ligand भी same है, लेकिन ions are different in the aqueous solution. ठीक है?
Yes.
Okay. That type of isomers are called what? That type of isomers are called the ionization isomers. So आपको देखने से ही पता चलेगा कि this is ionization isomers. Clear? You will just see that whether the ions are different or not in the aqueous solution. If they are different, that is ionization isomerism. Next type, linkage isomerism. Linkage isomerism. Next type is linkage isomerism. See, I'm writing it over here. I'm just writing here only so that you can understand it from here on. Already you know it. Linkage isomerism. I'm writing it, suppose NO2 and Cl, and here I'm writing ONO and Cl. First of all, you see, are the isomers or not? They are isomers having the same molecular formula. How are they differing?
Sir,
How are they differing? Tell me. How are they differing? नहीं कहाँ पे डिफर कहाँ पे कर रहा है? So यहाँ पे एक है जो कि एम्बिडेंटेड लिगेंड
yes, yes,
डोनर साइट्स में डिफर कर रहा है, राइट?
yes, sir.
यस. आयंस सेम, यहाँ पे नेगेटिव आयन क्लोराइड है, यहाँ पे क्लोराइड आयन नेगेटिव है, so it cannot be ionization isomerism. So यहाँ पे N is the donor site, यहाँ पे O is the, so for the linkage isomerism there must be ambidentate ligand present.
Yes, sir.
Yes, where they're differing in the donor sites. Is it clear or not?
Yes.
Okay, that type of linkage is called what? That type of isomers is called what? That type of isomer is called linkage isomer. Means उसका link भी different होगा. Okay, coordination bond जो donor side देगा वो different होगा. Means ambidentate ligand होना है. अब कुछ भी लिखो ये यहाँ पे CN NC भी हो सकता है.
Yes, sir.
है ना? Yes, they are isomers, but their donor sites are different. Means they are ambidentate ligands, and that is why this type of isomers are called what? Ionization isomers. Okay.
The linkage isomer.
Linkage isomers. Is it clear?
Yes.
Okay. Next one is coordination isomer. Next one is coordination isomer. Coordination isomer. The coordination isomer में first point जो है, first point is that in this particular case, till now whatever we studied, everywhere we studied that either there is one complex ion, there is one counter ion. Okay. Complex ion is complex, counter ion is normal. That is what we studied till now.
Yes,
The coordination isomerism is found in those complexes or those coordination compounds where both the positive ion as well as the negative ion are complexes. That's the first point. Both positive ion as well as the negative ion are the complexes. Okay? That's the first point. There only we see the coordination isomerism. Okay? मैं लिख रहा हूँ आप automatically समझ जाएंगे. Cr suppose H2O whole 6. I'm just writing it. I mean, it's not that you have to remember it. CO Cl6. I suppose. This is a whole compound. Okay? Obviously, this is the positive ion. This is the negative ion.
yes, sir.
Right? Both are complexes. Both are complexes. Okay? It can show what? It can show the coordination isomerism. कैसे? Now another compound I am writing, you can understand that CO H2O whole 6 Cr Cl6. देखो molecular formula same है कि नहीं?
Yes, sir. Yes.
Yes. How are they differing? How are they differing? सेंट्रल मेटल, राइट?
Yes, sir.
एक में जो पॉजिटिव आयन का सेंट्रल मेटल है, दूसरे में वो नेगेटिव आयन का सेंट्रल मेटल, राइट?
Yes, sir.
Just central metal ion has exchanged their places. Yes? Understood that? Yes or not?
Yes.
This type of isomerism is called what? This type of isomerism is called coordination isomerism. Simple. कुछ नहीं है. Okay? The next one is hydrate isomerism. Hydrate isomerism. From the word itself, you can understand what should be it. Hydrate means water of crystallization, right? Hydrate isomerism. Okay? So यहाँ पे number of water of crystallization molecule will be different. Number of water of crystallization molecule will be different. For example, suppose if I write this, suppose Cr, okay, H2O, H2O whole 6, Cl3, okay, this is one complex. Okay, let me write it like this: H2O whole 5, Cl2 dot H2O. Okay, this is one, and another one I'm writing Cr. Simple, ये देखते का भी कुछ नहीं है. H2O whole 4, Cl2, Cl dot 2H2O. First you see whether they have the same molecular formula or not.
Yes, sir. Yes, sir.
They have the same molecular formula? Yes? Yes or not?
Yes, sir.
Fine. How are they differing? Number of water of crystallization molecule. Right? In certain case, in one case the water of crystallization is 1, in another case the water of crystallization is 2. That water has gone as a ligand in first case. In the second case, ligand से water of crystallization हो गया. ठीक है?
Yes.
This type of isomers are called what? This type of isomers are called hydrate isomers. Is it clear?
Yes, sir.
Fine. So that's all about the structural isomer. Structural isomer आपका यहीं पे खत्म है. This is all about the structural isomers. ठीक है? Okay. Now we are coming to stereoisomerism. Okay. Stereoisomerism can be of two types. Stereoisomerism that we had seen in class 11 also, but again I am saying stereoisomerism can be of two types. One we call geometrical isomerism. Geometrical isomerism. Generally geometrical isomerism, in general we call them cis-trans isomerism. Can you remember that? Same side,
Yes, sir.
in the same side, similar groups are in the same side cis, similar groups are in the opposite side trans. Okay? Cis-trans geometrical isomerism, generally we call them as cis-trans isomerism. Okay? And obviously the other type is optical isomerism, which also we studied. Optical isomerism means dextrorotatory, levorotatory. Okay? Mirror images of each other.
Yes.
Non-superimposable mirror images of each other. Okay? Optical isomerism. Okay? So geometrical and optical isomerism. So first we are going to start with the geometrical isomerism. Fine? Now in our syllabus, this isomerism, stereoisomerism are there for coordination number 4 and coordination number 6. Okay? So we are going to do that only. So first we are going to study the geometrical isomerism for coordination number 6. Geometrical isomerism for coordination number 6. तक कुछ नहीं है, एकदम सिंपल. जस्ट आपको समझना है geometrical of coordination number 4. Sorry, 6 नहीं, 4 करते हैं पहले, है ना? 4 और 6 है तो 4 करते हैं, ठीक है? Okay. Coordination number 4 का geometrical isomerism. Geometrical isomerism. Geometrical isomerism. Okay. Now, what is geometrical isomerism? Already we know. Cis-trans isomerism, right? Means if similar groups, in this particular case ligands, okay, same ligands are in the same side means cis, same ligands are in the opposite side means trans. Okay, we know this. Fine. Now coordination number 4, please listen to me very carefully. Each and every point I am saying is very important. Coordination number 4 means there can be two types of geometry. One is tetrahedral, and another one is square planar, right? We know this. Okay, where these ligands are approaching from the four sides of a tetrahedron, and in another case the ligands are approaching from four sides of a square planar. Clear? Okay. This one is not going to show any geometrical isomers. Why not? Because tetrahedral geometry mein, all of us know, all of us have studied a lot of this, all four positions are equivalent. यहाँ पे कोई सिमिलर साइड या ऑपोजिट साइड नहीं होता है, राइट? टेट्राहेड्रल मतलब क्या? ऑल फोर पोजीशंस आर इक्विवेलेंट ओनली. आप इधर घुमाओ एक ही जैसे लगेगा, इधर घुमाओ एक ही जैसे लगेगा, है ना? सो यहाँ पे कोई सिमिलर साइड, सेम साइड या ऑपोजिट साइड नहीं होता है, राइट? So obviously this is not going to show any geometrical isomerism. So why tetrahedral complexes are not showing any geometrical isomerism? Because all four positions are equivalent in the tetrahedral geometry.
Yes.
Okay, so there is no question of it to show the geometrical isomerism. Is it clear?
Yes.
Okay, now in case of square planar. In case of square planar, suppose this is central metal ion, I'm writing it like this. In general, let us do, then specifically we will do. Okay, that types we will do. Mn plus is there, and the ligands are approaching from the four sides of a square. Clear?
Yes.
Okay, and let us number it as 1 to anywhere. 1, 2, 3, 4. Okay, it is attacking from number 1, attacking from number 2, attacking from number 3, attacking from number 4. Okay, if the similar ligands are placed, if the same ligands are placed either at 1 and 3, their opposite,
Yes, sir.
or at 2 and 4, their opposite. So these pairs are called trans pairs. Okay, these pairs are called trans pairs. Okay, if they are placed in 1 or 2, 1 and 2, or 2 and 3, or 3 and 4, any other. Okay, they're all what? They're all cis pairs. Is it clear? So when it is trans, when it's the
Sir, can you please repeat?
yes, if the same ligands are placed at 1 and 3, they are in the opposite side.
Yes, sir.
If they are in the opposite side, that is trans.
Yes, sir.
Or if they are placed in 2 and 4, they are opposite side.
Yes, sir.
So these two pairs are the trans pairs.
Yes, sir.
Yes, any other pair, if the similar ligands are placed at 1 and 2, or they are placed at 2 and 3, they are all cis pairs.
Yes, sir.
Yes, understood that? So there are only two pairs which are trans. What are the two pairs? 1 and 3 and 2 and 4. Is it clear?
Yes, sir.
Clear or not? Now, which type of complexes show the geometrical isomerism in case of square planar? The first type, types showing the geometrical isomerism in square planar, coordination number 4. The first type, say I am writing in general, first type, M, A2, B2 type. M, A2, B2 type. M is central metal, A is one ligand, B is one ligand, and these are monodentate ligands. ओके मैंने ए भी लिखा मतलब आपको भी ए भी लिखना पड़ेगा बोल के कुछ नहीं है, आप एक्स वाई पी क्यू कुछ भी लिख सकते हो. ठीक है, एम इज मेटल, बाकी आप कुछ भी लिगैंड लिखो. ठीक है, फॉर एग्जांपल सपोज जस्ट लेट मी टेक एन एग्जांपल पीटी NH3 whole 2 Cl2. Yes, is it of that type?
Yes, sir.
Yes. Okay, now if I tell you to draw the, can it exist in cis and trans? Can it exist in cis and trans? Yes. Can I draw the cis structure? This is square planar. Okay. PT नहीं, अभी आपका मन में ये आता है, suppose how do you know sir it is a square planar? Or how do you know that it is a tetrahedral? That we will see the theory when we will study next day. Okay. But at this moment, you know, we are only dealing with a square planar structure. Because tetrahedral हम लोग निकाल दिए.
Yes.
हमारा कंसेप्ट से टेट्राहेड्रल निकाल दिया. ठीक है. So PT NH3 whole 2 Cl2. मैंने आपको सिस लिखने बोला. सिस लिखने बोला तो दोनों NH3 आपको सेम साइड में लिखना है. कहीं भी लिखो आप. दोनों NH3 आपको सेम साइड में लिखना है. दोनों क्लोरीन आपको सेम साइड में लिखना है. यस. ओके. फाइन. और अगर ट्रांस लिखने बोलेंगे तो क्या है? ऑपोजिट साइड में लिखना है. सिंपल है बेटा, सिंपल. PT दिस इज, आप लिखो कहीं पे भी, यहाँ पे NH3 लिखेगा तो दूसरा NH3 कहाँ होगा? यहाँ पे होगा.
Yes, sir.
यस, यहाँ पे Cl होगा, यहाँ पे Cl होगा. दैट इज ट्रांस. ओके, इज इट क्लियर?
Yes.
नाउ दिस पर्टिकुलर कंपाउंड, व्हाई डिड आई राइट लाइक दैट? एनी कंपाउंड गिवन यू कैन राइट ऑन द cis and trans structure of this type, Ma2 B2 type. Okay, now this compound specifically I had written the example. This particular compound commonly is called platin. You know the IUPAC name. IUPAC name में मैं नहीं जा रहा हूँ. Common name of this is platin. Okay, platin. Why did I write down this particular compound? I think I told you in class 11 also this particular thing. Okay, platin. Now platin can exist in cis platin or trans platin, right?
Yes, sir.
Okay, platin can exist in cis or trans form. Okay, cis platin or trans platin. Out of that, cis form of platin is a very, very important compound in the treatment of cancer. Okay, cisplatin, that question also sometimes comes. Cisplatin is a very, very important compound in the treatment of cancer. Cis form. Okay, so you can understand the difference ऐसे नहीं कि दोनों कंपाउंड सेम है, दोनों का जियोमेट्रिकल आइसोमेरिज्म में वैरी है, मतलब प्रॉपर्टी में कितना वैरी है। ट्रांसप्लेटिन का कोई रोल नहीं है कैंसर ट्रीटमेंट में, बट सिस्प्लेटिन का ह्यूज रोल है कैंसर ट्रीटमेंट में। तो हम लोग सोच सकते हैं कि अरे सिस्प्लेटिन और ट्रांसप्लेटिन में डिफरेंस क्या है, वो तो सिर्फ अलग अलग जगह में है, लेकिन उसका प्रॉपर्टी ही चेंज हो जाता है। ओके, प्रॉपर्टी कंप्लीटली चेंज हो जाता है बिकॉज ऑफ दिस पोजिशंस। ठीक है, ओके, सो दैट इज वन टाइप, फर्स्ट टाइप। ओके, सेकंड टाइप इज आई एम राइटिंग इट लाइक दिस, सपोज second type is M A2XY, M A2XY. Okay, for example, suppose again I am writing PT NH3 whole 2 ClBr. Can I write it? समझ गया बात? ऐसे नहीं कि मैं याद करके लिख रहा हूं, आप समझ में आ गया। ओके, दो सेम सिमिलर मोनोडेंटेड लिगेंड है एंड टू डिफरेंट मोनोडेंटेड लिगेंड्स है। ओके, है ना? आई जस्ट रोट द मोनोडेंटेड लिगेंड, आपको ऑलरेडी पता है मोनोडेंटेड लिगेंड क्या है, सो मैंने लिखा है इसको। कैन इट शो द सिस और ट्रांस आइसोमेरिज्म?
Yes, sir.
Yes, with respect to whom? With respect to NH3, right? With respect to A, right? Yes, X and Y cannot determine whether it is cis or trans, right?
Yes, sir.
Okay, similar ligands has to be, so if I tell you to write down the cis and trans form, you can write down this.
Yes,
Okay, इसका लिख ले, इसका कॉमन का लिख ले, है ना? So M A दोनों साथ में, है ना? X and Y that is cis. Okay, and अगर A with respect to A only we can write ना, A opposite में, X and Y opposite में, that is trans. Is that clear?
Yes, sir.
Clear? Okay. The next one is next type, the last type, which undergoes, which shows the geometrical isomerism. Geometrical isomerism, again I am saying geometrical isomerism. Okay, is the third type is M A B X Y type. For example, suppose PT, मैंने NH3 लिखा था, एक NH3 लिख रहा हूँ, एक वाटर लिख रहा हूँ, ठीक है? एक NH3, एक वाटर, एक Cl, एक Br, चार अलग अलग लिगेंड है, राइट?
Yes, sir. Yes, sir.
ओके, चार अलग अलग मोनोडेंटेड लिगेंड है। आई सेड इट विल शो द जियोमेट्रिकल आइसोमेरिज्म। विल इट शो सिस ट्रांस आइसोमेरिज्म? क्यों नहीं दिखाएगा? क्योंकि सिमिलर लिगेंड्स है ही नहीं।
Yes, sir.
Similar ligands are not there, okay? So there is no question of it to show the geometric cis-trans isomerism, but it will show the geometrical isomerism. कैसे geometrical isomerism दिखाएंगे और कितना दिखाएंगे? देखो सिंपल है, कुछ नहीं, very just understand it, okay? It will show 3 geometrical isomerism. कैसे 3 geometrical isomerism दिखाएंगे? देखो यहाँ, just see it over here. M, okay? 4 ligands are, I'm writing A, B, X, Y, anywhere I'm writing A, B, X, Y. Okay? Keep any one of the ligands position fixed. Any one of the ligands position fixed. Suppose I am keeping A fixed. So this is one structure. In this structure, A is trans with X. Okay? Then I will keep the position of A fixed and will rotate the others. Means B यहाँ पे आ जाएगा, यहाँ से यहाँ पे आ जाएगा, X यहाँ से यहाँ पे आ जाएगा, and Y यहाँ पे आ जाएगा. Now A is in trans with whom? B. In the first case, A was in trans with X. In the second case, A is in trans with B. Okay? We will rotate once more. Once more. So M, A is there, Y यहाँ पे था, यहाँ पे आ जाएगा, B यहाँ पे था, यहाँ पे आ जाएगा, X यहाँ पे आ जाएगा. Now A is in trans with whom?
Y.
Y. If I rotate once more, back to the first one, right? Yes?
Yes, sir.
If I rotate once more, back to the first one?
Yes, sir.
Yes or not? Okay? So how many isomers are possible? 3 isomers are possible. And they are trans with respect to a specific ligand. Clear?
Yes, sir.
Okay? But these are, we cannot say that this is cis isomer or this is trans isomer. These are 3 geometrical isomers that is possible. Is it clear? Understood that?
Yes, sir.
Okay? So this is the geometrical isomerism. This is all about the geometrical isomerism for coordination number 4. What do you know for geometrical isomerism for coordination number 4? First of all, coordination number 4 can have two types of structures, tetrahedral and square planar. Out of that, tetrahedral is not going to show the geometrical isomerism because all four positions are equivalent positions. Okay. Square planars are going to show. Okay. And what type, how many types of square planars can show? 3 types. We have seen that. Okay. And third one is the special one. Clear?
Yes, sir.
Then we are coming to coordination number 6. Coordination number 6. Geometrical isomerism of coordination number 6. Geometrical isomerism for coordination number 6. Okay. Now geometrical isomerism for coordination number 6. What is the shape of coordination number 6? The shape of coordination number 6 is octahedral. We know it, right? One ligand is coming from here, one 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 is coming from top, one is coming from bottom. Yes, that's the shape of octahedral structure. Clear? Now we will number it. Again, we will number it. This is number 1, number 2, number 3, number 4, number 5, and number 6. Clear? 6 positions are there. Okay, fine. We're numbering it 1, 2, 3, 4, 5, 6. So 1 and 6 generally write top and bottom. Okay, and 2, 3, 4, 5 anywhere in the square planar you can write. Okay, out of these positions, the trans pairs are 1 and 6. If similar ligands are present at 1 and 6, they are trans. Okay, if similar ligands are present at 2 and 4, that is trans. Yes. And if the similar ligands are placed at 3 and 5, that is trans. Right?
Yes, sir.
Okay. Whatever remaining pairs are there, they are all cis. Both are the remaining pairs, but they are all cis. Is it clear?
Yes, sir.
Okay. If you understand this, there is nothing. Now the types. The first type, you can draw it very easily. The first type, M, A2, B4. Yes? Possible?
Yes, sir.
Possible? Yes or not?
Yes, sir.
How it is possible? With respect to whom? A or B? Both? Can you put B, 4 B's in cis position or trans position? नहीं कर सकते हैं ना, है ना? So with respect to whom you have to do? Only A? 2 A है, 2 A को आप cis में डाल सकते हो या तो trans में डाल सकते हो.
Yes, sir.
Okay, so write down the cis form of it. M, दोनों A कहीं पे भी डालो, ये दोनों डाल दिया A cis में. Yes, and remaining positions will be B. Now आप नहीं बता सकते हो B cis है या trans है ना? ये दोनों भी तो trans है.
Yes, sir. Yes, sir.
है ना? ये दोनों फिर cis है, बाकी सब cis है.
Yes.
So you cannot say B is cis or trans. We can determine only with respect to A. Is it clear? Okay. And if I ask you what is the transform? What is the transform? All of you can say that has to be done with respect to A only. अब कोई भी पेयर में डालो. 1, 6, 2, 4, 3, 5 कोई भी पेयर में दोनों A को डालो. और बाकी 4 positions you write cis. I mean B. Yes. Okay. And B जैसे डालेंगे आप देखेंगे कि B का पोजीशन सिस भी हो रहा है, ट्रांस भी हो रहा है, so you cannot say in that with respect to B. Is it clear?
Yes, sir.
That is one type, first type. Okay, that is first type. The second type is again second type shows geometrical isomerism, not cis trans isomerism. Okay, that is M A3 B3. MA3B3 type. Obviously ये cis trans तो दिखाएगा नहीं. 3 तो है. 3 तो we cannot put in the cis position or trans position. Anyone will go to cis and trans both. We cannot do this, right? Okay. But it will show two geometrical isomers. कैसे two geometrical isomers दिखाएगा देख. सीधा है, simple है. Just understand it. That's all. Okay. This is octahedral. This is the octahedral structure. I'm just trying to draw it. Okay. This is the top part of it. Top part of the octahedral. Yes. Same way the bottom part is also there. How many faces are there in the top part? कितना फेस दिख रहा है आपको? 4 फेस दिख रहा है?
Yes, sir.
सामने एक ठो है, इधर में एक ठो है, इधर में एक ठो है, पीछे एक ठो है. And what is the shape of each face? Triangular. Shape of each face is triangular.
Yes, sir.
Means 3 point है, 3 ligand point है. Okay. If the 3 similar ligands are responsible for the formation of any face, one face. For example, suppose I am taking this face. This face. This is the face. Yes. One A is here. One A is here. One A is here. So the same ligands are responsible for the formation of one face. Clear? So obviously the remaining 3 positions will be B. That will be also responsible for the formation of another face. That will be also responsible for the formation of another face. Means the similar ligands are placed in one face each. Yes?
Yes, sir.
Okay, that is one geometrical isomerism, and that type of geometrical isomerism is called facial isomerism. We call them facial isomerism, and in short, we write them as FAC. Okay, facial isomerism. Okay, understood that? So, if the 3 similar ligands are placed in the same face of octahedron, okay, 3 similar ligands तो cis trans तो हो नहीं सकता. Okay, now 3 similar ligands are placed in the same face of an octahedral. Clear? Then we call it facial. Okay, and if they are not placed in the same face of octahedral, if they are not placed, suppose दोनों A यहाँ पे है और एक A यहाँ पे है. Suppose दोनों A यहाँ पे है और एक ये तो सेम हो जा रहा है, ये भी सेम हो रहा है, कहाँ पे नहीं हो रहा है? 1 2 एक नहीं फेसियल कहाँ होगा? 1 2 और ये सपोज एक यहाँ पे एक, तो ये तो कोई फेस नहीं है, है ना? दिस इज नॉट अ फेस. अंडरस्टूड दैट? ओके, सेम वे इफ दिस B and B are there, this is also not a face. Okay, that means if the similar ligands are not placed in the same face, if they are not placed in the same face of the octahedron, then they are called meridional geometrical isomer. They are called meridional geometrical isomer, and in short we call MER. Okay, so FES and MER isomerism. Clear? These are obviously not cis trans isomerism. They show FES and MER isomerism. Is it clear?
Yes, sir.
Is it clear? Okay. One more type is there. One more type is there which shows the geometrical isomerism in case of octahedral structure. What is that? MAA whole 2 x2. Now what is AA whole 2? Please understand it. It is, I said it is octa, it is coordination number 6. अब बताओ तो coordination number 6 कैसे हो रहा है ये? A क्या है? नहीं obviously ligand है. कौन सा टाइप का ligand है? Bidentate ligand है, right? A bidentate ligand है तो अभी ये 6 होगा ना?
Yes, sir.
2 into 2
Yes, sir.
plus this. Okay. Now whenever I write AA within the bidentate ligand can be of 2 types. See, you must know all these things. Okay, bidentate ligands can be of 2 types. I wrote one AA, and in some certain other cases you can find it as AB. The difference between AA and AB is AA is a symmetric bidentate ligand, okay, and AB is asymmetric bidentate ligand. For example, suppose ethane diamine आप लोगों ने लिखा CH2 CH2 NH2 NH2 EN लिखा नहीं? Yes. Is this symmetric bidentate ligand?
Yes, sir.
Very much symmetric. Yes, this is symmetric bidentate ligand. Yes, but if I write this, suppose CH2 NH2 NH2, यहाँ पे C double bond O negative. This is the donor side. This is the donor side. This is also a bidentate ligand. Yes, but what kind of bidentate ligand it is? Asymmetric bidentate ligand. Okay. Now, which is going to show the geometrical isomerism? It's the symmetric bidentate ligand. दो symmetric bidentate ligand होगा और दो monodentate ligand होगा. ठीक है? For example, suppose if I write CO En, right? This is denoted by En, right?
Yes, sir.
En whole 2 Cl2. Yes? Okay, it's going to show the geometrical isomerism.
Yes, sir.
Yes, obviously it will show the geometrical isomerism with respect to X, the monodentate ligand. Yes?
Yes.
So what is the structure? See, it's very simple. We write down the structure like this. Okay, this is M. Okay, now two A's are here. What is this? A नहीं तो क्या लिखा? X लिखा ना? Okay, X are here and here. What is this? This. Okay.
Yes, sir.
Now bidentate ligand AA, one AA suppose is occupying these two positions. We write it like this, like the arc we write AA. One AA is occupying this position and this position. Yes, and another AA is occupying this position and this position. Clear? So this is the C structure. Yes or not? Yes. And what should be the trans structure? You can write in different manner. But it's better to understand to write in this particular manner, and you will write in this manner. 2x will be here. Trans, top and bottom.
Yes, sir.
Trans, yes.
Yes, sir.
Now 2 A's, one AA will be here, one AA will be here. Yes, occupying these two positions,
Yes, sir.
and one AA will be here, occupying another two positions. Clear? That is transform of it. That is transform of it. Is it clear?
Yes, sir.
Clear? So that's all about geometrical isomerism. About geometrical isomerism we had finished. Now what we had left over with the optical isomerism,
Yes, sir.
ठीक है, और दो थ्योरी, ठीक है, उसमें से है वैलेंस बॉन्ड थ्योरी एंड क्रिस्टल फील्ड थ्योरी, ठीक है, उसमें ये कार्बोनिल ग्रुप नहीं है, आपका सिलेबस से हट गया वो, ठीक है. सो ऑप्टिकल आइसोमेरिज्म एंड
Theories.
theories, two theories. Out of that, one theory will finish next day.
Yes.
Okay, and one. So 2 more days. 2 more days will finish. 2 more days will finish everything rather. तो 2 दिन भी नहीं चाहिए, शायद 1 दिन में भी हो सकता है.
Yes.
ठीक है, लेकिन आप लोग क्या करेंगे? What you are going to do? You are going to start solving the questions till where it is done and specifically the nomenclature and all. ठीक है, वो आपको concept ज़्यादा बढ़ाएगा. ठीक है, चलो, thank you.